Dear students, now we are going to examine the relationship between AC and MC. This relationship is quite familiar to you. This is because we have learned earlier in microeconomic theory the relationship between average cost and marginal cost using graphs. And we know that both these curves are U-shaped curves. For instance, we can draw that curves AC and MC. That is, suppose we have on the x-axis output, and on the y-axis let us show average cost and marginal cost. And first let us draw the average cost curve. Let us draw it as a U-shaped curve. This is our AC. And how do you draw the MC curve? MC curve is also a U-shaped curve. And we can say that initially MC, it lies below the AC, and then it passes through the minimum point of AC, and then it is above AC. This is how it looks like. AC and MC, both of these curves are U-shaped curves, and we know this relationship which states that as long as MC is below AC, whenever MC lies below AC, throughout that portion we can see AC curve is falling. Then MC is passing through the minimum point of AC. After that, we can see that MC is above AC, isn't it so? MC is greater than AC. So at that, during that levels of output, or in this portion, we can see AC is rising. So this is how the relationship between MC and AC exists as per this graph. Now, this is what we are going to examine using mathematical equations. Okay, now let us see how does it look like. Of course, we know that both MC and AC, you get it from total cost curve, isn't it so? Because MC means it is the first derivative of total cost function, isn't it so? TC is the total cost curve, and we can write MC as MC is equal to DTC by DQ, isn't it so? That is, marginal cost is the first derivative of total cost. Similarly, we know that AC is also something you get from TC, where you can write AC is equal to TC by Q. Okay, so both these MC and AC curves, you derive it from total cost curves, where MC is DTC by DQ and AC is TC by Q. Now let us write TC, or total cost, as C into Q. Right, C is per unit cost and Q is the output. So total cost is nothing but per unit cost multiplied by total output that is produced. Right, for instance, let us say that the per unit cost of producing a commodity is 10 rupees, and you are producing 100 units of that commodity. Okay, so in that case total cost is equal to 10 into 100, that is equal to 1000. That is how you arrive at the total cost, that is per unit cost, which is C multiplied by output Q, that will give you total cost. Now, if this is the total cost, C into Q is the total cost. From this, you get AC as TC by Q. Of course, you know that it is TC by Q, or in other words, it is C into Q divided by Q. Okay, you can write average cost as CQ by Q. Right? Now, what we are trying to do is that we are trying to find what is DAC by DQ, or we are finding the first derivative of average cost function. We are trying to differentiate average cost with respect to output, or what we are trying to do is that, of course, you know that average cost can be written as TC by Q, which is equal to CQ by Q. So with this can be written as D by DQ of CQ by Q. Right, CQ by Q, that is the average cost. We are taking the first differentiation, okay, first derivative of CQ by Q, okay, D by DQ of CQ by Q. Right, now of course here we can apply the quotient rule, isn't it so? Because here we have two differentiable functions, it is CQ divided by Q. So these are two differentiable functions. So here we can apply, when you differentiate average cost with respect to output, we can here apply the quotient rule. Of course, you know that if f of x is equal to g of x divided by h of x, how do you apply differentiation? by using quotient rule, you write that as h of x into g dash x minus g of x into h dash x whole divided by h of x whole squared. That is how you apply the quotient rule. Similarly, here also, here we have two differentiable functions, eq by q, and you are differentiating d by, that is this with respect to q, that is d by dq of cq by q. So here we can write this as, how can you write this? That is, this can be written as, this is the denominator, q is the denominator. So we can write this as q into, right, first derivative of cq. First derivative of cq can be written as c dash q, right, q into c dash q minus, and here we have the numerator cq into first differentiation. Okay, when your derivative of q, that is dq by dq, that is equal to 1, isn't it? When you take the first derivative of the denominator q, that is dq by dq, that is 1, cq into 1 whole divided by, and we know that h of x whole squared, that can be written as, here it is denominator is q, so that can be written as q squared. Now we simply rewrite this. We can write this as q into c dash q by q square minus cq into 1 is of course cq by q squared. This can be again rewritten as this q, and in the q square one of the q's gets cancelled out. So this can be written as c dash q divided by q minus, here we can write this as that is cq by q squared. You can write it as cq by q squared. Okay, here this q, okay, q into c dash q, in that this q and one of the q's in q squared will get cancelled out. That's why we write this as c dash q by q minus, here we write as cq by q squared. Now here what we do is that here we can take out, we can factor out 1 by q, because here also you have in the denominator q, here also of course you have q squared, right? So you can easily factor out 1 by q. When you factor it out, you have what is remaining, it is c dash q. Here when you take out 1 by q, what is remaining here is c dash q minus cq by q square. Here factored out 1 by q, so this becomes cq by q, right? Okay, so this is we are taking 1 by q out of the brackets. Okay, so what remains is 1 by q into c dash q minus cq by q, and this can be again written as, what is this actually, 1 by q into what is c dash q? C dash q is nothing but first derivative total cost, it is nothing but marginal cost, minus what is cq by q? CQ is total cost divided by output, that is nothing but average cost. So this is what we have got when you differentiate it. What we are actually doing, we are differentiating DAC by DQ, isn't it? We are differentiating the average cost with respect to output. We are taking the first derivative of average cost with respect to output, or we are finding what is the slope of the AC curve, that is equal to, when you do that by applying quotient rule, when you do that, we get 1 by q into mc minus AC. What have you actually done here? You are applying quotient rule. You take the denominator q into the first derivative of numerator, that is c dash q, minus numerator is cq into first derivative of denominator, that is dq by dq, it is 1 whole divided by q squared. And here what can you are rewriting this, here what you do, q into c dash q by q squared minus cq by q squared, and here you take out that is, first of all you that is cancel out this q with one of the q's here, so this becomes c dash q by q minus cq by q squared, and that is equal to, how can you rewrite this? You take out of bracket 1 by q, and that is written as 1 by q into c dash q minus cq by q, and the c dash q is nothing but it is mc, and cq by q is nothing but ac. So we can say that dac by dq is 1 by q into mc minus ac. So here we can say that dac by dq can be greater than 0. When this can be greater than 0, that is when MC is greater than AC. Only when MC is greater than AC. Okay, this only if the value of MC is over and above AC, you can say that this term will be positive. Okay, for values of Q greater than 0, right? This term will be positive only if MC is greater than AC. Only if MC is higher than AC, for values of Q greater than 0, you can expect the slope of AC to be greater than 0, or slope of AC to be positive. On the other hand, what happens to DAC by DQ for values of Q greater than 0? Suppose MC is less than AC. Okay, suppose this term MC is less than AC. Of course, we know that this entire term for all values of Q greater than 0, this entire term, it will go negative, isn't it? So it becomes less than 0. So whenever MC is less than AC, whenever the marginal cost is lying below AC, we can say that the first derivative of average cost or the slope of AC will be less than 0, because this term would become negative. Okay, so this is how we have derived the relationship between average cost and marginal cost. Graphically, this is how we present, and from this graph it is quite obvious that whenever MC is less than AC, AC is falling, isn't it? Here MC is less than AC for levels of output greater than 0. We can say that you get a negative slope for AC. That is why AC is falling. Now, whenever MC is greater than AC, isn't it? Whenever MC is greater than AC, here we can say that the entire term would become positive, and that is why DAC by DQ is greater than 0. Okay, thank you, students.